right, so we did triangles as one type of polygon. Now we're going to do quadrilaterals. And we already said quadrilaterals have 4 sides. There's that prefix quad, which means 4. So we have a lot of characteristics of quadrilaterals to talk about. First of all, they're always going to be closed figures. All quadrilaterals have angles which equal 360 degrees, like a square, all of those. Angles equal 360 degrees. Then we want to say that they're always 4-sided. All the sides are straight. And they're 2-dimensional. Quadrilaterals. Now, there are 2 types of quadrilaterals in the whole category. Well, there's a lot of different types within it, but we can classify them as convex or concave. Convex means that any line I draw within 2 points within the polygon or the quadrilateral, they're not going to leave the interior of that quadrilateral. So for example, if I drew this, that has 4 sides, any point I draw that's from one point to another is going to go inside that quadrilateral. But if I drew it like this, that's not going to work. Let me just get my picture here. If I draw it like this, it's going to be 5 sides. 1, 2, 3, 4, 5. I'll just show it to you like this. It's a concave polygon is what it is. But I could do this with this, and do you see how the line goes outside of that quadrilateral, or outside of that polygon? Okay, so now we'll talk about the different kinds of quadrilaterals, and there are quite a few of them. We're going to start with the parallelograms. A lot of quadrilaterals are parallelograms. And it really goes right with the name. Parallel means it has parallel sides. So quadrilaterals that are parallelograms have 2 pairs of opposite sides which are congruent. So let's draw one over here. Here's a parallelogram. You can see, because of my tick marks, that these 2 sides are congruent and these 2 sides are congruent. 2 pairs of opposite angles are congruent. 2 pairs of parallel sides. And the symbol for parallel is 2 straight lines like that. Not absolute value. Absolute value has more space in between. So 2 pairs of parallel sides. So you can see this is parallel to this. They're never going to touch. And this is parallel to this. Never going to touch. Okay, parallelograms can be squares. Could be a rhombus. And it can be a rectangle. These are all parallelograms. We're also going to discuss each one of these, but they do fall into the category of parallelograms as well as something like this. Okay, so let's start with the square. So I'm going to erase this, and now we're going to go to squares. What do we know about squares? Well, we know they have 4 congruent sides. 4 congruent angles. We also know that it has 4 right angles. So we know that those 4 congruent angles are 90 degrees each. We have 2 pairs of parallel sides. And we know that squares are rectangles. This is a question you'll see a lot. Squares are rectangles, but are rectangles squares? No. A square is a rectangle because we're going to do rectangles next. You're going to see that the qualifications for a rectangle, the square matches those. But the rectangle does not match all the qualifications of a square because it has to have 4 equal sides and rectangles do not. So a square is a rectangle, but a rectangle is not a square. All right, so next we're going to move on to rectangle. So a rectangle, again, is a parallelogram. We already said that, so I'm not going to write it. I didn't write it here either. It has 2 pairs of parallel sides. It has 4 right angles. And opposite sides are congruent. So here's your rectangle. These 2 sides are congruent, and these 2 sides are congruent. This is a right angle, right angle, right angle, right angle. It's a parallelogram, has 2 sides, opposite sides are parallel. And you can see that it's not a square, because a square has to have 4 equal sides. But a square follows, it has 2 pairs of parallel sides, it has 4 right angles, and it has opposite sides which are congruent. So that's why the square is a rectangle, but the rectangle is not a square. Okay, so from here, we're going to go to a rhombus, another parallelogram. Okay, a rhombus is a lot like a square. It has 4 congruent sides. It has opposite angles are congruent. That's what's different about a square and a rhombus, because in a square all the angles are 90 degrees. 2 pairs of parallel sides. And diagonals bisect or cross each other. At right angles. So let's look at a rhombus. A rhombus looks like this. It almost looks like a diamond. It looks like a diamond is what it looks like. So all 4 sides have to be equal, and this angle matches this one, and this one matches this one. Remember those little arcs? 2 here and 2 here mean these are equal. 1 here and 1 here means those are equal. If I drew the diagonals, I would draw one like this and one like this. Do you see that it made 4 right angles? Okay, from the rhombus, we are going to the kite. The kite is kind of a funny looking thing because it looks like a kite, just exactly what you'd expect. Adjacent sides, there's one of your vocabulary words. Adjacent means sides that are equal to each other, or next to each other. And the adjacent sides here are equal or congruent. 1 pair of angles are congruent. and no parallel sides. So a kite looks something like this. And you can see that the adjacent sides are congruent. This is congruent to this, and this is congruent to this. One pair of angles are congruent. This is congruent to this. I really think two pairs can be congruent, but at least one. And no parallel sides. They're all going to intersect. It really is made of two triangles. Has that same quality that you can if you bisect the diagonals, you get right angles. Okay, and then the last thing we're going to talk about is the trapezoid. The trapezoid is another quadrilateral, and it's going to have adjacent angles which are congruent. It's also going to have a pair of parallel sides which are called the bases. And I'll show you that in just a minute. The legs, so the sides not parallel are called the legs. And an isosceles trapezoid is a trapezoid where the legs are equal. Legs congruent. So let's draw some pictures of trapezoids, because they can look a little bit different. You can have a trapezoid, and this is probably the kind that you're used to seeing, that looks like this, where this side and this one is identical to that side. These two are not the same length. This would be an isosceles trapezoid. Then you can have a trapezoid that looks like this, in which none of the sides are the same. It's called a scalene trapezoid, but you don't really have to know that. And in this case, it's just sitting up this way. So in this one, this is the base, this is the base, this is a leg, and this is a leg. In this one, this is your base, this is your base, this is a leg, and this is a leg. How do I know these are the bases? Well, I know they're the bases because they are the two parallel sides. The parallel sides, if they're sitting this way or this way, are the bases. Okay, next time we're going to talk about perimeter and area of all of these quadrilaterals.